Welcome to this week's midweek space news roundup. So in this video, I'm just going to go over some space news articles I found on websites and on social media. So first of all, let's bring this up here, this banner. We're on X at Space Startup Hub. So with that, let's get into the first news article. And this is just a series of X posts on Astrolab. They've been quite busy recently on social media, so I just want to get up to speed on what they're doing at the moment. So this X post, they talk about their Flex rover is designed to use whatever tools are needed for lunar operations. That includes tools like this excavator drum designed by UCSB students. The tool recently got new use by company Astrolab, which I've covered on this channel already, and they're working on lunar landing pads and lunar roads, basically lunar infrastructure. During testing in our lunar simulant sandbox. So Astrolab is working on lunar rovers. They already have small micro rovers on the moon, but they're working on a LTV or lunar terrain vehicle. So NASA is running a competition for a Artemis LTV rover, which can carry 2 crew around the surface of the moon. It can also be used remotely or teleoperated. One of the companies is Astrolab with their Flex rover. There's also Lunar Outpost and Intuitive Machines Moonracer. So anyway, let's have a look at these images. So you can see it's a Flex rover chassis, but in the front you've got this excavator drum. And the way it works, if we look at this second photo, it spins around and it can dig up lunar soil, which could then be transported somewhere else. I just moved out of the way, whatever. So that's very interesting, and the Flex rover has a number of tools, or end effectors as they're called. It has a robotic arm for scooping up lunar soil or placing things on the surface. But let's move on to the second X post. So this says, when Flex lands on the lunar surface, it will be the largest and most capable rover to ever travel to the moon. But while getting there, it becomes much smaller. Flex was designed to fill less cargo space during its ride to the moon and deploy to full size once on the surface. We actually have a video showing that process. So let's run the video. So you can see it starts out as a box, and then when it's on the ramp, it can deploy its legs and also solar panel, and it can gently move onto the lunar surface, which is very interesting. I've not seen this before. So I think this is a new render. So there we go. That was the second media post. So let's move on to the third. So this one says, we've taken our Flex rover from animation to real hardware. From the tires to the crew stand. We put our rover to the test in clean rooms, in the field with NASA astronauts and more. And they've also included a video. So let's have a look at that. Myself in the corner here. So you can see that that's a robotic arm. It can put experiments on the surface. It can dig up lunar regolith. Here it's deploying some kind of mast for solar panels. And that's a Blue Origin Mark 1 lunar lander. And then it's picking up some cargo. And then you've got crew moving around. That's NASA astronauts. So they've got the hardware built already and they've been testing it for a while. Hyper-deformable tires from Venturi, I believe. So that's a very interesting video from them. So we have another post here. This says, we're continuing our partnership with Volditure as they develop a lightweight, redeployable 25 to 50 kilowatt solar array system designed for transportation and deployment from our Flex rover. This is just one example of how Flex will support the construction of lunar infrastructure. So I'm not familiar with Volditure, but we have a few images here. So this is before deployment. You can see it at the front here. That is the solar panel arrays in their folded state orientation. And then once fully deployed, it looks like that. And that can produce 25 to 50 kilowatts of power, which is a substantial amount of power. So that is all the information we have from social media posts from Astrolab. They're one of the 3 companies trying to get the LTV award from NASA. And hopefully we'll hear about that award definitely sometime this year. We're waiting for the Commercial Space Station Awards, Phase 2, and we're also waiting for the LTV Awards from NASA. So there's quite a lot happening this year in terms of funding from NASA. So we'll see what happens. And hopefully the other companies that don't get the NASA award will still continue to commercially develop their LTV. All the vehicles look good, and hopefully they'll find commercial partnerships. Okay, our next story is on Varda Space. We have this ex-post from them. Put myself in the corner. So the W-5 mission, which is their 5th re-entry capsule. So Varda Space is working on the in-orbit manufacturing of materials or pharmaceuticals or drugs. And then they have this re-entry capsule technology so that the materials can be recovered and returned to the customers. So W-5 is the first in-house built satellite bus that Varda Space have used. Previously, they were using a satellite bus made by Rocket Lab, but now it's all in-house. So they managed to vertically integrate a re-entry capsule with their own designed satellite bus. And they're making the heat shield themselves now as well. So the W-5 mission landed safely at the Kaniba test range operated by Southern Launch. This is in Australia. This is the first re-entry of Varda's next generation satellite bus, which we designed specifically to meet the demands of both long-duration orbital pharmaceutical processing and re-entry. The W-5 flight carried a payload for the US Navy in partnership with Air Force Research Lab and was also equipped with a heat shield made in Varda's El Segundo headquarters from C-PICA. It stands for Conformable Phenolic Impregnated Carbon Ablator. So PICA is just a NASA technology. The C means conformable, which means they can wrap it around the front of the capsule to create a nice, tight, snug fit. So C-PICA, as it says, it's an ablated material that has been used on all the W-series capsules and was originally developed at NASA Ames Research Center. So the key highlights of the W-5 mission are end-to-end autonomy. The mission was a successful demonstration of the Varda-built bus in executing orbital maneuvers, concluding in a precise deorbit burn, high-fidelity recovery, safe landing, and rapid recovery of the customer payload for immediate post-flight analysis, saves time, and offers customers options for iterative development. And hypersonic S&T, the unique aerothermal chemistry of the re-entry environment is impossible to fully simulate on the ground, and flight testing is the best way to advance understanding of the re-entry environment. W-5's success reinforces the advantage of building the entire integrated system in-house. By owning the spacecraft, the capsule, and the mission operations end-to-end, we can iterate faster, fly more often, and reliably bring complex manufacturing processes back to Earth. So a few interesting observations about W-5. First of all, both W-4 and W-5 were in space in orbit at the same time. So as they're getting higher and higher cadence, the operations are becoming more complex. Operate 2 vehicles in space at the same time. And that will simply just increase as you get more customers and more missions. So this is why the end-to-end autonomy is really important. We do have a few photos of the landing. This is the W-5 re-entry capsule with the parachute deployed, and we can also see it coming into the atmosphere. So initially it's coming in at Mach 25, and obviously it slows down and then deploy a parachute, and it lands very gently, and then they can recover the pharmaceuticals. And we also have this other social media post at the end of last year, and it explains the different re-entry capsules. So W1, that the very first mission, showed it can be done. W2 proved it can be repeated. W3 made it routine. W4 made it business as usual. And W5 is now in orbit, well now it's just landed, and gave us 2 vehicles in space with multiple customers. Just another day at Varda. Varda is now moving from development into operations. So they have customers such as the US Navy, very interested in the properties when traveling at hypersonic speeds. Obviously, the US is building hypersonic missiles and counter-hypersonic weapons. So they're hitching a ride on Varda Space capsules, which routinely experience Mach 25 when they come into land. That's very useful for the US Navy, and also it's a customer for Varda Space. But they also have customers generating pharmaceuticals and drugs in space. So we'll keep an eye on them and see how they do in the future. So let's move on to our third story this week. So our next story is on Lunar Outpost, that is building a lunar terrain vehicle that can provide mobility for NASA Artemis astronauts. So let's have a look at this post. Security and exploration beyond Earth demand speed, adaptability, and innovation. At Lunar Outpost, we prioritize rapid iteration and vertical integration because the future can't wait. We've developed 7 Eagle lunar terrain vehicle prototypes in 12 months, MAP flight models in record time. MAP is a smaller lunar rover. Proven, high-capable systems operated on the Moon and Mars, achieving TRL-9 on Lunar Voyage 1. TRL stands for Technology Readiness Level. It goes from 1 to 9. TRL-9 means it's reached full operational capability, it's flight-proven, and basically it's something you can buy. A flight-proven software suite, Stargate, Mars, and Spark, unifying operations, autonomy, and data to enable operator to asset scaling from 1-to-1 to 1-to-1000 plus. We're building systems that are precise, resilient, and ready to accelerate the timeline for missions that matter. So that's the post, but it comes with a number of images, so let's have a look at those. So you can see the Eagle vehicle here, and 2 astronauts can sit at the front. This is side on. You can see the partners. You've got General Motors, Goodyear, MDA Space, Leidos, and the NASA logo there. And we have this one. So you can see that the crew can exit or enter at the front. They've got steps there at the front. And I think there's one more. This is not the full Eagle vehicle, but you can see the wheels in some kind of lunar regolith simulant environment. So they're entered into the NASA LTV program, competing with Intuitive Machines Moonracer and the Astrobotic Flex rover. NASA is likely to pick one of those, but in addition to that, they also have a commercial mission scheduled with SpaceX on the Starship vehicle. So this is from 2024, but it's relevant. Let's just read this. So Lunar Outpost signs with SpaceX for Starship Moon mission. So this is November 2024. They signed an agreement to deliver Lunar Outpost lunar terrain vehicle to the Moon aboard a SpaceX Starship. And the vehicle provides surface mobility for future NASA Artemis astronauts, and it can be used to establish critical infrastructure, enabling sustainable commercial access to the lunar surface. So you can see here a render of the Eagle vehicle, and you have the Apollo vehicle, the LRV or Lunar Rover vehicle in the background. That's from the 70s, and now you have the upgraded 2020 version, and here you have Starship. So it goes on to say, Lunar Outpost Eagle, Lunar Outpost LTV is being developed as part of NASA's Lunar Terrain Vehicle Services contract, supporting both manned and unmanned missions. And it has the ability to operate during harsh lunar night conditions, which is very important because 50% of the time the sun is not above the horizon and it gets very cold. If you don't have the ability to survive the lunar night, then you have a dead asset. The vehicle just dies. Most landers and lunar assets die after 2 weeks when the sun goes down. It's a problem that needs to be solved for the lunar terrain vehicles because they have to last for decades. The lifespan of these vehicles is 10 plus years. So anyway, that is the last story this week. So thank you for watching. And in terms of my next video, I've done a video this week on orbital data centers from StarCloud. I'm going to continue that with SpaceX wants to put 1 million AI compute satellites in orbit to basically build data centers so it can scale data centers, which it doesn't believe can be done on Earth. It has to be done in space. We'll dive into that on my next video, which will probably be out Friday. So thank you for watching, and if you haven't, please like and subscribe, and I'll see you next time.